Karnaugh Maps. Karnaugh Maps is basically a way to simplify a Boolean circuit. So instead of having so many 1, 2, 3, 4, 5, 6, 7, 8, let's say 8 gates, right? You can simplify this by saving costs. If you simplify, you're going to save costs by using the least amount of gates to get the same output, right? Okay, so let's start. So the first step here is to represent the problem in a binary format, right? So for example, if we have W naught, for every complement, we're going to represent that specific variable with a 0, and then no complement, it will be a high. For example, here it's W naught, so this will be a 0, for example, 0, right? And then the X will be a 1, then the Y will be a 0, and then the Z naught will be a 0 as well. Okay. Just for our problem to be neat, let's do it here. So W, that's a 0, X1, Y0. So it's going to be 0, 1, 0, 0. The next one, W is 1, 1, 0, 1. 1, 1, 0, 1. Right? The next one, 1, 1, 0, 0, 1, 1, 0, 0. Right? The next one, 1, 0, 0, 1, 1, 0, 0, 1. The next one, 0, 0, 1, 1, 0, 0, 1, 1. Next, 0, 1, 1, 1. 0, 1, 1, 1. Next, so here, 1, everything is a 1. 1, 1, 1, 1. Next, 1, 1, 1, 0. 1, 1, 1, 0. Okay, so here we have a 4-variable Karnaugh maps. So this is the number of variables that we have, 1, 2, 3, 4. So that's why we have a 2 to the power 4, which is 16 cells Karnaugh map, right? So sometimes they will tell you to put WX in the rows as rows and YZ in the columns. So in this case, because they didn't say anything, we're just going to put WX as our rows and then YZ as our columns. Let's do that. So we're going to have the first variable is going to be WX, right? Will be the second variable. Y will be the third variable. Z will be the fourth variable, just like in this case. All right. So let's number the Karnaugh map. So this will be 0, 0. This will be 0, 1. Check here. This is not 1, 0. This is 1, 1. Because a Karnaugh map is shaped like a tennis ball. 1, 1, 1, 0, right? Even here, 0, 0, 0, 1, 1, 1, 1, 0. So now we're going to plot the main terms, right? So we're going to place, because this is in SOP format, we're going to place a 1 where we get this combination. So where W is off, X is on, Y is off, and Z is off, we're going to place a 1 there in that specific cell. So let's see, 0, 1, 0, 0, 0, 1, 0, 0 is here. We have a 1, 1, 1, 0, 1, 1, 1, 0, 1, another 1, 1, 1, 0, 0, 1, 1, 0, 0, another 1, 1, 0, 0, 1, 1, 0, here it is, 0, 1, here. 0, 0, 1, 1, 0, 0, 1, 1. A 1 here, then all ones, a 1 here, then triple 1, 1, 1, 1, 0, 1, 1, 1, 0. Here it is. So how many terms did we have? 1, 2, 3, 4, 6, 7, 8, 8 times. So we should have 8 number of ones here. Let's see. 2, 3, 4, 5, 6, 7. So it's very good to do that so that you can see if you missed out anything. So let's see, what did we miss out? 0, 1, 0, 0, 1, 1, 0, 1. It's here. 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, triple 1, all ones, and then triple 1, 0, 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let's check here. 1, 2, 3, 4, 5, 6, 7, 8. They are 8. 0, 1, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so we missed this one. 0, 1, 1, 1. Okay, here it is. All right. So from here, we need to group Karnaugh maps, right? So when you group Karnaugh maps, you look for the biggest group. Grouping, you look for the biggest group, right? Biggest group. So you can group the biggest group, for example, here will be in groups of 8. Biggest group. So the biggest group will be 8, right? Groups of 8. Then the next will be 4. Then the next will be 2. Then the next will be 1. So if we don't find 8 adjacent ones next to each other, we look for 4 adjacent ones next to each other. If we can't find them, we look for 2 adjacent ones. If not, we group that individual cell alone or variable alone, right? Okay, so now let's look for 8 adjacent ones next to each other. We don't have 8 adjacent ones next to each other, right? So the biggest group can be 8 ones, right? So now then we look for 4. 4 adjacent ones. This is the first group now. The first group, it's this one. So what do we have here? All right. So here we have, how do we simplify? To simplify, we look for variables that do not change states, right? Let me type it here. No change in state, right? Okay, what do I mean by that? I mean W must remain the same, X must remain the same, Y must remain the same, and Z must remain the same. Then we will take those variables if that's the case, right? Okay, let's see. Let's simplify this. So here we're going to have W in this group. W is in row 3, right? 1, 2, 3. It's only in row 3. So it means the value of W will always be 1. It will not change states because W's group, this group does not contain another value for W. It only has a single value for W, right? Which is 1. So here we will have W, because it's high. If it's 1, it's high, right? W, and then X, it's 1 in this group. It doesn't change states because this red group only has 1 row, right? Then we'll have our X here. Now let's go to the Y and Z. Y in this group contains of 4 columns, 1, 2, 3, 4, right? Y is 0 in the first one, Y is 0 in the second one, but Y becomes 1. So Y changes state. So we're not going to take it, we throw it away, right? Then Z. Z is 0 in the first column, then Z is 1. So we're not going to take it, we throw it away. So this is the simplified version of this group. You are done with this group. We can go to the next one. Okay, so now we're gonna look. We found 4 adjacent ones. Do we have any other 4 adjacent ones next to each other? No, we don't have. So we look for 2. 2, we have 2 here. We have 2 here. We have 2 here. We have 2. Okay, we have a lot of 2s. Anyway, okay. Let's start with this one. In this group, what do we have? In this group, we have W is 0. This group contains of 2 rows, right? You can see the rows here. W is 0, W is 1. So we don't take it, we throw it away. X is 1 and X is 1. So we take X because it does not change state. It was 1 in this row and then it's still 1 in this other row. Now let's look at Y. Y in this group, there's only one column. So Y will always be 0 and Z will always be 0. So we take both of them because they are 0, they are complemented. Y complement Z complement. All right, so now let's look for another group. Another group, it's this one, and this one. Let's group them together. All right, so in this group consists of 2 rows. W is 1 in the first row and W is 1 in the second row. So we take W as it is because it does not change states, right? Then X is 1 and X is 0. So we throw it away. We don't take it because it changes states, right? In this group, still in this group consists of one column. Y is always 0. Z is always 1. 0 is a complement, right? W, Y complement because it's 0. And then Z is high. Great stuff. So now another group, it's this ones. So in this last group, what do we have? We have, in this group consists of 2 rows. We have W to be 0 and W to be 0. So W does not change states. So we need to take W because it's 0, it's complement W. W complement, right? Then X, in this group, X is 0, X is 1. It changes states, so we throw it away. This group consists of only one column. Y will always be 1 and Z will always be 1. So we take them as they are. Y, Z. So this is basically the simplified version. This is basically this expression simplified. Thank you.